Hello students, once again I am very happy to meet you in our next videos. It is Kulisandro Deka from Jigyasa Education. It is about a chemical reaction and equation, a chapter of class 10 science chemistry. In this chapter, we'll discuss various aspects of chemical changes, reactions, and as well as equations. We have already uploaded a number of videos on this chapter. In this video, we'll write about chemical equation. What is chemical equation, and how a chemical equation is written. How to balance a chemical equation will come in the next videos. Let's come to the definition. How we can define a chemical equation. A chemical equation is a symbolic representation of chemical reaction in the form of symbols and formula of reactants and product or products. It is a symbolic representation. We use here symbol and formulas of the reactants and the products. You know, reactants means that those substances which take parts in the reaction initially, and the products is with those substances or substance which is produced after the reaction is completed. That means the reactants take part in the reaction, and after the completion of the reaction we get some products. It may be one product or maybe more than one products. So what happens in chemical equation, we represent the whole reaction in a symbolic way. We do not write the names of the chemical substance that take parts in the chemical equation. No doubt we can form some word equation as the initial stage, and thereafter finally we replace the words by symbols and formulas. Let's come to the ways how to write a chemical equation which represent a chemical reaction. Let's take an example. When magnesium ribbon is burnt in oxygen in the presence of air, when there is sufficient oxygen, it gets converted to a white powder called magnesium oxide. This description of the chemical reaction is very long. We can express it in a shorter way. The simplest way to do this is to write this reaction in the form of a word equation. That means to express the chemical reaction in a short form, we have to write a chemical equation in the form of symbols and formula. Before going to that, we should write a word equation which represent the reaction. Say the reaction between magnesium and oxygen. When magnesium ribbon is burned in the presence of oxygen and magnesium oxide is produced, it can be expressed with the help of a word equation which is magnesium plus oxygen on the left hand side and magnesium oxide at the right hand side. Magnesium plus oxygen, it is the reactants that take part in the reaction. And again, what happens after the reaction, we find this as product. That means magnesium oxide is the product. Magnesium oxide, the product is written on the right hand side, and the reactants are written on the left hand side. In the we express the whole fact, the whole reaction in the terms of the name of the reactants and products. Magnesium and oxygen are the two reactants here, and on the right hand side, the magnesium oxide is the sole product, only product. So that's why one product is mentioned here. Again, what happens when there are two reactants or three reactants? These two reactants are added with a plus sign. If there are another reactants, then we will place the plus sign here. Similarly, if the products are more than one, what will happen? We have to use plus sign here, but here is only one product, so no plus sign is used here. So in this way, we express the chemical reaction in the form of a word equation. The substance that undergo chemical change in the reaction, here magnesium and oxygen, are the reactants, and the new substance formed during the reaction is the product. Here magnesium oxide is the product. A word equation shows the change of reactants to products with an arrow placed between the reactants and the products. The reactants are written on the left hand side of the arrow with a plus between them. That means between the reactants. If the number of reactants is more than one, then we should place a plus sign in between them. Similarly, the products are written on the right hand side of the arrow with a plus sign between them. Then the same way, on the right hand side, we write the products, and if the product number of products is more than one, then we place a plus sign in between them. The arrowhead points towards the products and shows the direction of the reaction. Here, the example, the magnesium plus oxygen, here are the reactants. And here are the products. So what happens? The arrowhead is towards the products. It shows the direction of the reaction. That means the reaction takes place from this to that. These are the reactants, and they produce this product. So reaction, it is the direction of reaction is indicated by this arrow mark, and arrowhead is towards this side. That means the reaction, the direction of the reaction is from this to this side. That means magnesium and oxygen get combines, and what happens? Get combined, and then they will produce magnesium oxide as the product. So this arrowhead points towards the products, and it shows the direction of the reaction. Now let's represent the reaction with the help of an equation. That means chemical equation having symbols and formula in place of chemical names of the reactants and products. That means now we are going to replace the names of the reactants and products by their symbols and formula. The above mentioned reaction between magnesium and oxygen can be represented with the help of these symbols and formulas this way. This is the symbol of what? Magnesium. We know that the magnesium molecule consists of one atom. Metals are made of one atom. The molecules of metals are made of one atom. So what happened? We write magnesium in this way, only Mg. It is the symbol of its atom as well as molecule. Similarly, the molecule of oxygen consists of two atoms of oxygen. That's why we write O2 here. O is the atom. It is the symbol of oxygen, and we write 2 here because the molecule of oxygen consists of two atoms. and it produce magnesium oxide MgO. Since the valency of magnesium is 2, oxygen is 2, so its symbol will be, formula will be Mg2. This is a compound and it will be Mg2O2, but as there are two after magnesium, 2 after oxygen, so it is written as MgO. So we write here MgO. So we find a reaction as an equation, Mg plus O2, that is equal to after the arrow mark we get MgO. That means here Mg plus O2, these are reactants, symbols and formula of reactants, and it is the formula of product. Now see what happens. We know that the formula, that we know the principle that of a conservation of mass in the reaction. So there is no change of mass after and before the reaction. That means the mass that the reactants have conserves. That means the mass of the products, total mass of the products and the total mass of the reactants must be same, because no mass is created and destroyed in a reaction. No new mass is created and no mass is destroyed here. So what happens? There should be equal number of atoms both in the reactants and the products. So what will happen? We have to equalize the number of atoms of each reactant, which is written on the left hand side, and also the same number of atoms of each element should be there on the right hand side. That means in the products also. So if we notice this reaction, what will happen? What happens? See here, 1 atom of magnesium but 2 atoms of oxygen. But here what happens? 1 atom of magnesium and 1 atom of oxygen. So what happens? The number of atoms on the left hand side of the elements of the reactants are not equal to the number of atoms present in the product. This type of equation is called skeleton equation. Here, this is a skeleton equation. This is a skeleton equation. This type of equation, in which the number of atoms present in the reactants and the number of atoms present on the product are not same, and this type of equation is called skeleton equation. So what happens now? We have to balance it. That means we should balance the number of atoms of every elements present in the reactants as well as in the product. So let's try to balance it, to equal the number of elements, number of atoms of the elements and present in both sides. Here to find out the maximum number of atoms present in the member of the reactants and as well as products. What will happen? Here is 1 magnesium, here is 2 oxygen atoms, 1 magnesium and 1 oxygen atom. So maximum number is 2, and here now that is maximum number. Oxygen has the maximum number of atoms on the left hand side, that means in the reactant sides. And now find out the number of oxygen. Here is 1, and find the LCM of lowest common multiples of these two numbers, that is 2. So what will be the lowest common multiples of 2 and 1? That will be 2. So LCM will be 2. So now we try to make the number of product number of atoms of oxygen equal to its LCM 2. So to make the number 2 atoms, here we have no other alternatives but to make 2 molecules. That means we have to write a 2 before MgO. We write a 2 MgO. It represents that 2 molecules of magnesium oxide. Then what will happen? In 1 molecule of magnesium oxide, 1 oxygen, and in 2 molecules there are 2 oxygen. So what happens? The number of equalizing the number of oxygen, the problem of number equalizing the number of oxygen is solved till then. But what happens? Another problem arises. In 2 molecules of magnesium oxide, there are 2 magnesium atoms. But here we find only 1 magnesium atom. So we have an easy way. Sometimes the way may not be easier like this, but we'll come to another video how to balance a chemical equation in another video. But here it will be very longer. So what will happen? We use this simple form, this simple way to balance this equation. Later we come in the next video how to balance some complex equation, chemical equations. So what will happen? Here are 2 magnesium. So we write 2 here. So 2 here, that is. So what happens now? Here the skeleton equation is written here. I will write it in a different place. So it is the skeleton equation. Now we will write the balanced equation of the chemical reaction. This is the balanced equation, twice Mg plus O2 twice MgO. Now we have found a balanced equation of the chemical reaction here. Let's take another example. Hydrogen and oxygen combines with each other and to form water, which is H2O. Here we'll find that 2 reactants are there, hydrogen and oxygen, and one product is here, H2O. Now what happens then? If we want to represent this chemical reaction with the word equation, we'll write hydrogen plus oxygen on the left hand side of the arrow mark and water on the right hand side of the arrow mark. So now we try to represent this reaction with symbols and formula. Here we write the symbols of what happens, formula hydrogen H2 because one molecule of hydrogen is hydrogen consists of 2 atoms of hydrogen, so you write H2 below here. Similarly, in one atom in one molecule of oxygen, and there are 2 atoms of oxygen, so we write O2 here. Again, the formula of water is here is hydrogen and oxygen. The valency of hydrogen is 1, oxygen is 2. So what will happen? 2 comes here, 1 comes here. So what will happen? It will be H2O1, and we do not write the 1, that is H2O. So the formula of water is written here. So, but what happens? Here the number of hydrogen atom is 2, number of oxygen atom is 2, but here the number of oxygen atom is only 1, not 2. That means the number of atoms of each element that take part in the reaction is not equal. So we have to balance it. That is skeleton reaction. Chemical equation is here. We find a skeleton chemical equation. Now to balance it, what will happen? See the maximum number of atoms present in the molecules. Each molecule each reactants, and you check the its reactants and its products. What will happen here? 2 hydrogens atoms, 2 oxygen atoms. Here hydrogen 2, oxygen 1. So maximum number is hydrogen. Hydrogen has 2 number of atoms on both sides. So there is nothing to do to balance the equation, because the number of hydrogen atoms present on both sides is 2. But the problem arises here. Oxygen has 2 atoms on the left hand side, that means in the reactant sides, and one atom on the product side. So what will happen? Let's try the LCM 1 and 2. The LCM of 1 and 2 will be 2. So we'll try to make the number of oxygen 2. So what will happen? We have found already 2 here. Here is only 1 oxygen. So what will happen? In 1 molecule of water contain 1 oxygen atom. So when we make the number of molecule 2 here, what will happen? 1 into 2, there will be 2 number of oxygen atoms. So now we add a 2 before H2O. Now let's examine what happens. Here 2 oxygens, and here what happens? A hydrogen is 2, but what happens here? See, the number of hydrogen has become 4 because in 1 molecule of hydrogen there are 2 hydrogens atoms. But after balancing, in the process of balancing, when we add 2 here, what will happen? 2 into 2, 4 atoms of hydrogen on the right hand side. To do this, to equalize, again we try another method. Here are what happens? 4 hydrogens. Here is 2 hydrogens. So LCM of 2 and 4 will be 4. Since 2 is the product of 4 or 4 is the multiple of 2, so automatically their LCM will be 4. So what will happen? Now we'll try to make it 4. Here contains 2 atoms of hydrogen. When we added 2 into 2, that is 4 atoms of hydrogen here on the left hand side. Now what happens? The number of hydrogen atom becomes same. So let's examine again. 2 into 2, 4 atoms of hydrogen, 2 atom of oxygen. Here 2 atoms of water. 1 atom contains 2 hydrogen. So 2 into 2, 4 atoms of hydrogen. 1 atom of water contains 1 molecule. So 1 molecule of water contains 1 atom of oxygen. 2 molecules contain 2 atoms of oxygen. So what will happen? The number of hydrogen and oxygen and the number of hydrogen and oxygen present in the reactants and the number of hydrogen and oxygen present on in the product side are same. So we have found a balanced chemical equation of this. So what will happen? I have already said that I have taken the simplest form of equation here. So thereafter in a separate video we will elaborate how to establish, we will show you how to balance a chemical equation taking some complex large chemical equations, that means chemical equations containing large number of molecules, different numbers of varied numbers of atoms in the products as well as reactants. So till then I want to say you goodbye. We'll meet in another videos. Thank you very much for watching these videos. Keep on watching our videos and then we'll meet you again in our next videos. Thank you very much.